Relative velocity. To discuss relative velocity, let's consider this illustration. Suppose we have a man riding a train, a moving train, with a velocity of 9 meters per second. And he is walking in the aisle of the train at 2 meters per second. So for the point of view of the other passengers inside the train, the velocity of the man walking is 2 meters per second. Now, let's consider the point of view of another observer, which is outside of the train, let's say at the ground base. He can observe that the velocity of the train is 9 meters per second. And considering the man walking along the corridor or along the aisle, at the point of view of the observer outside, the velocity of the man is 11 meters per second. So we can have the equation of the velocity of the passenger relative to the ground is equal to the velocity of the passenger relative to the train plus the velocity of the train relative to the ground, which will give us the value of 11 meters per second. So let's take note of this. The subscript for our vector sum is passenger to the ground. We have P and G. A symbol for the passenger and ground, and T is for the train. Okay, so at the right side of the equation or the equal sign, we have the summation of the velocity of the passenger P relative to train plus the velocity of the train relative to the ground. Okay, so the component P and G here must be P at the first side and G here at the last side. And T, which is in between of P and G, will be eliminated in the vector sum. Okay. So also you have to take note of this, that okay, take note of this, that if we reverse the velocity, or we take the velocity of the train relative to the passenger, so the VPT is reversed, it is equal to the negative V PT. Okay po. So meaning of this that if the subscript is being interchanged, it will result to a negative value, or it is directed at the opposite direction. Let's say if the man walk against or at the opposite direction of the velocity of the train, let's say it moving backward, it's going to have a negative 2 meter per seconds. Therefore, his speed or the velocity of the passenger relative to the ground will be equal to negative 2 plus 9, which will equal to 7 meter per seconds. Okay, so let's consider this example. The engine of a boat drives it across a river that is 1,800 meters wide. The velocity of the boat relative to the water is 4 meters per second, directed perpendicular to the current, as in the figure, which will be shown at the next slide. So the velocity of the water relative to the shore is 2 meters per second. So, what is the velocity of the boat relative to the shore, and how long does it take for the boat to cross the river? So we have here the illustration. And the given. So this is V B W, the speed of the boat relative to the water. This one is the velocity of the boat relative to the shore. And this is the velocity of the water relative to the shore. So we are looking for the velocity Bs of the boat relative to the shore. So using the formula as illustrated in the last slide, we can say that the velocity of the boat relative to the shore is equal to the velocity of the boat relative to the water plus velocity of the water relative to the shore. And as given, we have the values for velocity of the boat relative to water, which is equal to 4 meter per seconds. And for velocity of the water relative to the shore is 2 meter per seconds. So it is the operation of this is vectorially. Okay, this is not algebraically. We're not going to just add this one because we are dealing with vectors. Velocity are vectors. Therefore, we have to solve for the x component and y component. Okay po. So, first, let's solve for v vs x. Okay po. So, vby, does it have a x component? So, the velocity of the boat respect to relative to the water has a 0 x component. And for VWS, it is equal to 2 meter per seconds. Therefore, our VVS is 2 meter per seconds. Okay, now let's solve for the y component. Does By has a y component? Yes, which is 4 meter per seconds. Does BWS has a y component? No. Therefore, our VBS is 4 meter per seconds. Okay? So we can solve now for the final velocity, which is the square root of the yx component and yx and y component. Okay, which is equal to square root of 4 squared plus 2 squared, equivalent to 4.47 meter per seconds. And for theta, just do the arctangent of the y component over x component. This one will result to 63.43 degrees. So this is our answer for the final velocity of the boat with relative to the shore. Okay, for part B. So how long does it take for the boat to cross the water? To solve that, we are going to use the formula of velocity is equal to displacement over elapsed time. So we're looking for t. Therefore, t is equal to the displacement, which is 1,800 meter over the velocity of the boat with respect to shore with its y component. Okay, so this one is y component, which is equal to 4 meter per seconds. Therefore, the time it takes is 450 seconds. Okay, so let's have another example. So the figure shown in the next slide are two cars approaching an intersection along the perpendicular roads. The car have the following velocities. So we are looking for BVA, VAV, or velocity of the car A as measured by the passenger in car V. So here's our illustration. Okay, so we are looking for VAB, which is equal to VAG plus VGB. Okay, so VAG, we have the value for VAG, which is 25 meter per seconds. And for BJ, where VGB is the opposite of this one, 15.8. Therefore, it is equal to VAG plus negative VGB. Okay, so first let's solve for the x component of VAB. So we have the x component for VAG, which is 25 meter per seconds. Okay po. And for VBG, it has a 0 x component. x component. Therefore, we have here the final x component of VAV, which is 25 meter per seconds. And for the y component, VAVY, VAG has 0 y component, and VBG is 15.8 meter per seconds. So we're going to have negative, of course, negative 15.8 meter per seconds. Okay, so sorry, I have to erase this one. This one should be negative BVG. Okay. So now we already have the x and y component of the velocity of car A with respect to the passenger in car B. We can solve now for this one. By doing Pythagorean theorem, therefore we have the final magnitude of 800, no, not 800, of 29.57 meter per second. And for the direction theta, arctangent of negative 15.8 over 25. Therefore, we have negative 32.29 degrees. So here's our final answer. Okay, so let's have your comprehension check by solving this problem and comment your answer in the comment section.